Today we will solve question number 5 part 3. Differentiate x square plus 1 divided by x square minus 1 with respect to x square minus 1 divided by x plus 1. Now we can easily see that there are two terms, this one and this one. And how to solve this? First of all, we will suppose this term. How to suppose? By naming. We consider this term as y is equal to x square plus 1 divided by x square minus 1. Similarly, we consider this term. For example, z is equal to x square minus 1 divided by x plus 1. Now, we name this as equation 1 and we name this as equation 2. In differentiate, if there is no supposition, for example, this term is not supposed by any term. So in differentiation, we will first of all suppose, and we will suppose by taking any variable a, b, c, whatever you want to write. So here I consider y. Now second step is differentiate, and differentiate with respect to whatever variable is in the right side. Here variable is x in the right side, so we will differentiate with respect to x. Differentiate equation 1 with respect to x. Now, and we can see that this equation is in the term of quotient, so we will apply quotient rule. And what does quotient rule say? According to quotient rule, dy by dx, u by v, if there are any two variable, what we will do? V derivative of u minus u derivative of v whole divided by v square. Now here we apply quotient rule. D by dx, differentiate with respect to x, d by dx, y. Now this term we consider as u, and this term we consider as, this whole term we consider u, and this whole term we consider as v. Now v is x square minus 1 derivative of u is this term, x square plus 1 minus u is this term, derivative of v is x square minus 1 whole divided by v, x square minus 1 v square. Now what we will do? Dy by dx as it is. X square minus 1 as it is. Derivative of x square. Here we apply power rule according to power rule. What does power rule say? N x n minus 1. N is 2. X 2 minus 1 becomes 1. So there is no need to write 1. So derivative of x square is 2x and plus 1. 1 is constant and derivative of any constant is 0. So there is no need to write 0. Next, minus x square plus 1 as it is. And derivative of x square is 2x. And derivative of minus 1. Minus 1 is constant. So derivative of any constant is 0. Whole divided by x square minus 1 whole square. Now we'll take common 2x. We can see that 2x is common from these two terms. What is x square minus 1 minus x square plus 1 whole divided by x square minus 1 whole square. Now x square minus 1 as it is, minus into minus plus minus x square minus plus minus 1 whole divided by x square minus 1 whole square. Now positive x square and negative x square cancel, minus positive x square minus x square cancel each other, minus 1 minus 1 minus plus 1 plus 1 2 sign minus. So 2x into minus 2 and x square minus 1 whole square. Now 1 2 2s are 4, x minus whole divided by x square minus 1 whole square, dy by dx. Now we will differentiate equation 2. Z is equal to x minus 1 divided by x plus 1. Differentiate equation 2 with respect to x. So this is also variable in the form of u by v, so we will apply quotient rule. Differentiate dz by dx. How to differentiate? This term we consider u and this term we consider v. So v is x plus 1, derivative of u is x minus 1. Why we differentiate with respect to x? Because in the right side variable is x, so we'll differentiate with respect to x. v derivative of u, use this term, minus u, use this term, derivative of v is x plus 1 whole divided by v square, x plus 1 square. Now x plus 1 as it is, derivative of x is equal to 1. Derivative of minus 1 is 0, because minus 1 is constant, so derivative of any constant is 0. Minus x minus 1 as it is, derivative of x is 1 and derivative of plus 1 is 0. Because plus 1 is constant, so derivative of any constant is 0. X plus 1 whole square as it is. Now x plus 1 minus plus minus x minus plus 1, x plus 1 whole square, plus x negative x cancel each other, plus 1 plus 1 plus 2, x plus 1 whole square. Now what we will find, we want to find differentiate dy, because in question we will see that in question, what does question say? Question said differentiate this term with respect to this term. It means if we consider this term this and this term this, it means we will differentiate y with respect to z. What does question say? Question said that differentiate this term, it means we will differentiate y with respect to this term. This term is z, so differentiate y with respect to z. It means dy by dz. And how it comes? Dy by dz, and we will other variable is x, so multiply and divide it dx. Now value of dy by dx is minus 4x by x square minus 1 whole square. Now derivative of dx by dt, we will take this term in the numerator because this is dz by dx and this is opposite dx by dt, so we'll x plus 1 in the numerator and 2 in the denominator. 2 and 2 cancel each other, 2 1s are 2 2 2s are, and minus 2x divided by x square minus 1 whole square, x plus 1 whole square. Now we can see minus 2x which is equal to minus 2x x plus 1 whole square, and this is a square minus b square whole square as it is. Now minus 2x x plus 1 whole square, because formula of a square minus b square is equal to a plus b into a minus b, and if x is a square minus 1 is a square, so what does it becomes x plus, first time we'll take negative 1, so first of all we'll take 1 as positive and next time we'll take 1 as negative, because a square minus b square is equal to a plus b into a minus b. This is whole square, so we put out whole square as it is, minus 2x plus 1 whole square. Now x plus 1 square and x minus 1 square, because this is whole square and these two terms are multiplied. So first of all we will put x plus 1 whole square, next time we'll put x square minus 1 whole square. Now if this term and this term cancel each other, both are square. What is left? Minus 2x x minus 1 whole square. So dy by dz is equal to minus 2x divided by x minus 1 whole square. This is our required solution.